The goal of this study is to determine how to collect post-mating semen from the female reproductive tract and how to measure semen liquefaction in mice. The animals used in this study were handled according to Washington State University Animal Care and Use Committee guidelines and in compliance with WSU-approved Animal Protocols number 4702 and 4735. In human, the ejaculated semen is deposited at the anterior wall of the vagina, adjacent to the ectocervix. In mice, however, the semen is swept into the uterus within minutes after mating. Semen contains seminal gel that is solidified within seconds of ejaculation, causing the sperm to be immobilized. The liquefaction process changes semen from a gel-like to a watery consistency. This process is essential for sperm motility and mammalian reproduction. The enzymatic activity of prostate-specific antigen, or PSA, is the major contributor for liquefaction through hydrolysis of seminogelins, or gel-forming protein present in the semen. Degradation of gel-forming protein liberates the sperm from seminal coagulum, increasing sperm mobility so that the sperm swim toward the upper female reproductive tract to fertilize the eggs in the fallopian tube.
The method for collecting semen from the female reproductive tract and the measurement of liquefaction time present in this study will provide researchers a novel diagnostic tool to determine whether liquefaction could be one of the causes of infertility in the modern organism of interest.
Next are the procedures where the mice are mated and vaginal plug is determined. Standard C57 Black 6 adult male mice or other strains of interest can be used. Only females at the estrus stage of the cycle were used. For detailed method for vaginal smearing and cytological analysis, please refer to the previously published procedures. At 4 p.m. on the day of estrus, the female was housed in a male's cage. The next morning, at 8 o'clock, the female is separated from a male's cage. Using a sterile flat toothpick, the presence or absence of a deposition of a vaginal or copulatory plug was assessed as an indication of mating, using a procedure adapted from a previously published method. Next is the procedure for preparation before tissue collection. Prepare a 10 ml of Leibovitz L15 media, supplemented with 1% fetal bovine serum or L15 media plus 1% FBS in a 15 ml tube. Warm the media at 37 degrees Celsius for 15 minutes. In order to preserve the viability of the tissue and sperm for downstream applications, aliquot 2 ml of media in a 2 ml tube for tissue collection. Warm the stage of the stereo microscope to 37 degrees Celsius. Set the heat block to 37 degrees Celsius. Place an empty tube in the heat block. Also warm the glass slide to 37 degrees Celsius if the downstream application requires imaging of sperm motility. Next are the procedure for tissue collection. Here are the tools that will be used for tissue collection. Euthanize the female immediately after shaking plug by using carbon dioxide as fixation, followed by cervical dislocation. Place the animal in a supine position to expose the abdominal area. Spray 70% ethanol onto the abdomen. Make a small cut, approximately 1 cm, on the skin on the lower abdomen. Pull the tail and the skin in opposite directions to expose the abdominal muscle. Cut the abdominal muscle in a V shape at the base of the abdomen. Move intestines and abdominal fat to the side to expose the reproductive tract. Trim off the bladder and other tissues above the vaginal area. Cut the pubic symphysis apart to gain access to the vaginal tissues. Pull the pubic symphysis bones apart using two forceps to expose the vaginal canal. Lift the vaginal tissue at the vaginal opening and use the scissors to separate the vaginal canal from the rectal tissue below. Carefully trim off the mesenteric fat from both sides of the uterus using spring scissors. The uterus is very fragile with the semen inside. Therefore, the investigator should be careful not to puncture the uterus or else the semen will be lost. Cut off the ovarian fat pad from both sides of the ovaries. Transfer the whole reproductive tract into the tube of pre-warm media. Next is the method for measurement of semen liquefaction. Here are the tools for semen collection. Transfer 3 ml of the warm media into 3.5 cm dish. Transfer the tissue into the dish. Wash the tissue several times by grabbing the fat pad. At this point, the semen should still be intact inside the uterus. Blot the tissue on Kim wipe to get rid of excess media. Hold the tissue at the vaginal end and put the tissue into the pre-warm tube by leaving the ovarian ends inside the empty tube. Cut both uterine horns between the vagina and the uterus. Let the semen flow out of the uterine horns into the tube. Use toothless forceps to gently squeeze and expel out leftover semen in the uterine horns. Briefly spin down the semen 1 to 2 seconds. Lay the tube parallel to the heated stage. Insert a 25 microliter capillary tube into the semen sample at a 180-degree angle. This is to minimize the variability between each investigator from holding the capillary tube at different angles. Record the time it takes for the semen to reach 25 microliter line. Liquefaction time is quantitated by the time taken to fill 25 microliter capillary tube with semen. Semen collected from control uteri took approximately 2 minutes to fill the capillary tube. However, the semen collected from knockout uteri took longer than 60 minutes of experimental time. These data suggest that the semen is significantly more liquefied in the control compared to the knockout uteri. Here is one of the examples of downstream application using video imaging of sperm motility. Use a pipette tip to pipette 25 microliter of the remaining semen onto the pre-warmed glass slide while the glass slide is placed on the heated stage. Cover slip the slide with a glass cover slip. Transfer the slide to the microscope by placing the slide cover slip down. Use 20x objective lens to find the sperm, then change to 100x objective lens for video imaging. Record the video at 12 frames per second for 30 seconds. The semen collected from the control uteri show freely swimming sperm within the microscopic field. However, the semen collected from the knockout uteri show that the majority of the sperm was clustered together with minimal mobility. These findings suggest that the semen collected from the female reproductive tract 8 hours after mating can be used for further analysis.
In addition to those downstream applications, the investigators can also evaluate the effect of the inhibitors or compounds of interest that interfere in different processes of the sperm transport. Processes such as sperm liquefaction, sperm number in the tract, sperm motility, or sperm migration at different areas of the female reproductive tract. The compounds can be applied in the female reproductive tract prior to mating. Then the impact of those inhibitors or compounds can be assessed from semen sample post-mating. These methods can be useful to test practicality of contraceptive drugs that inhibit sperm transport.